Hi everyone. I wanted to take a few minutes to go over the Immersitech Engage UC Core high-level architecture. And this really is designed as a summary to give you an overview of how the system works as a whole and what the different parts are in it and how they all work together. So let's start off at the top here. We've got the UC host system. This is the telephony system that's used for the web conferencing. It could be a combination of a media server plus a telephony server. It could be a number of different things. But it is the main point at which all the client applications will connect to when they're joining a video conference. So to adapt our system to any of these hosts, we have what we call the UC host adapter, and that allows us to capture the audio streams, which are shown in green, and the data, which are shown in blue, and translate those into a common language that our system understands. Different systems have different means of triggering events, different event architectures, and they even have different ways of passing the audio through. So this lets us kind of adapt ourselves to whatever the host system has. When we actually get the audio in a raw format, we'll pass it through to the core, and then any events that are captured are passed through to the core as well. And inside the core, we have three main components. We've got the sound manager, room manager, and event manager. I'm going to start with sound manager because that's the foundational part of our system. The sound manager provides three main functions. It provides the noise cancellation, the voice clarity, and this 3D spatial audio that really combined make our system unique. And it understands XYZ coordinates, and we can place a sound source at any one of those XYZ coordinates. And people often ask how that is done or how that's mixed, and we basically use a binaural mixing process by which we'll take all the audio inputs from participants, we mix together in combination with their location information. It's also provided as part of the data, and then we mix that and provide each participant with their own unique output audio stream that they can then listen to. So Sound Manager is the engine that drives all of the audio processing. That's kind of front-ended by Room Manager, and Room Manager is a kind of a convenience factor, but also is a great interface for creating the environments for any kind of a meeting. Room Manager, when the whole system starts up, Room Manager goes out and reads in a configuration file on the server. It's a JSON file that contains all of the information about different rooms that are available, room configuration types, the seating arrangements, anything from a large conference room to a boardroom to a huddle room. You can make a lecture hall, whatever you need. And all that information is loaded into Room Manager when it's started up. So when someone starts a conference, we can pick a room, or if you don't want to pick a room, it can just simply run on a default room that you've selected in that configuration file. But the Room Manager also manages the audio parameters for the room, so we can give it some more reverb, make it a little deader sound if you want to, a little brighter sound. We can do lots of little things to make the room a little more real, to kind of provide that real in-room experience. Event Manager is the system that really front-ends the API. This is the system that processes both the events coming in from the host adapter, from the host, but also receive commands from what we call this the client adapter. Really, the client adapter is nothing more than a set of functions that allows a client application to send information to our Event Manager API. And the reason why that's important is in order for us to coordinate where people are in the 3D audioscape, we need to have the coordinates. We need to tell what seat somebody's sitting in, for instance, in a conference room. Well, that information is passed along through a secure WebSocket through the API into Event Manager. Event Manager then tells Room Manager, say Dave is being moved from seat 1 to seat 3. It'll tell the Room Manager which seat and who's moving. Room Manager converts that to an XYZ coordinate because Sound Manager only understands XYZ coordinates. So the Room Manager performs that seat to XYZ coordinate mapping. The Sound Manager will then, on the fly, in real time, change the audio perspective of all the participants in the room and modify everyone's audio stream and send that updated information down the pipe so everyone can hear what's going on. So as In addition to receiving things through the API, we also will send out updates. So if a host moves a participant from seat 1 to seat 3, obviously that information is sent into Event Manager and then processed. But we also will send out an update to all other participants, letting them know that this user has moved seats. And then we let that client application use that information however they wish to. Many client applications will then change their UI to show somebody in a new location. It all depends on how that application works. Our demo application is a circular room, people sitting around a table. Other systems may have a grid-like video interface. There's lots of different ways you can do that. So we don't really tell you how to do this. We just give you the information to effect change. And then it's up to the developer to modify that client application to make the UI changes according to the information being sent. So we've covered the host system, the host adapter, Event Manager, Room Manager, and all the things it can do with seat to location mappings and the parameters it can manage in the room itself, and the Sound Manager, again with 3 components: noise cancellation, voice clarity, and the 3D spatialization. So I hope this has been helpful, and if you have any questions, please find us at immersitech.io. Thanks.